In this exercise, we'll find an equation of a line. We're given a point on the line, 2, 5, and we're told that the line we're looking for is perpendicular to the line x plus 3y equals 2. In order to find an equation for a line, we need a slope and a point on the line. Well, we're given a point on the line, but we aren't directly given the slope. But we're given enough information to find the slope of the line. Because we're told that the line we're looking for is perpendicular to x plus 3y equals 2. Perpendicular lines have slopes whose product is -1. If I can find the slope of this line, I can calculate the slope of any line perpendicular to it. So let's start by finding the slope of the line we're given. We have x plus 3y equals 2. I'm going to solve for y by subtracting x on both sides and then dividing by 3 on both sides. Y equals, the opposite of x over 3 is the same as -1/3 x, plus 2 divided by 3 would be 2/3. Now the slope of this line is -1/3. That is not the slope of the line we're looking for. The slope of the line we're looking for is some slope, m, where the slope of this line times m has to equal -1. Well, if I multiply everything by -3 here, let me write this out. This gives me -1/3 m equals -1. Multiplying everything by -3, I have m equals 3. Since -1/3 times 3 is -1, any line perpendicular to this line will have a slope of 3. And that's what we're looking for. So the equation of the line containing this point and perpendicular to this line will have a slope of 3. Now that we know the slope of the line and a point on the line, we can find an equation of the line, and we're going to do it using 2 methods so that we can check our answer. We'll start by using the point-slope form of the line, which is y minus y sub 1 equals m times x minus x sub 1. Now this has the advantage of being able to substitute directly from the known slope, m equals 3, and the given point, 2, 5. M is 3, x sub 1 is 2, and y sub 1 is 5. Substituting, I keep the y, that's my variable, minus y sub 1, which is 5, equals m, which is 3, times x, that'll be the variable x, minus x sub 1, which is 2. This is an equation of the line. Let's solve for y to write it in slope-intercept form. Y minus 5 equals, multiplying, I have 3x minus 6. Adding 5 to both sides of the equation, I have y equals 3x minus 1. This is an equation of the line. Now let's do this again using the slope-intercept equation of a line, y equals mx plus b. We're given that m equals 3, and a point on the line is 2, 5. To find this equation, this form of the equation, we need m and we need b. Well, we're given m, but we're not given b. We can find b, however, because we're given a point on the line. This must be true for every point on the line. In particular, it has to be true when x is 2 and y is 5. So if I substitute 5 for y, 3 for m, 2 for x, I can solve for b. I have 5 equals 6 plus b. Subtracting b from both sides, I have -1 equals b. Then I substitute -1 for b, 3 for m in this equation, and I have y equals 3x minus 1. Since this is the same as the equation I got earlier, that's a good check, and I can say that the equation of the line I'm looking for is y equals 3x minus 1.